Hello everyone, good day to you. And today we are going to cover the secondary 1 G3 topic of ratio, rate, and speed. Ratio, rate, and speed, just like other topics that have got great application in real life context, you will notice that the questions also vary quite widely when it comes to application. In this series, in this revision series, each handout focuses on one aspect of this topic. So handout 1 focuses on ratio, handout 2 focuses on rate, and handout 3 focuses on speed. Let's have a look at the questions in handout 1 now. So handout 1, first question is taken from Ang Mo Kio Secondary School, 2022, EOY, Paper 1, Question 4. Here we're given two pairs of ratios. The first ratio is P to Q, and the second ratio is Q to R. You will notice that in both ratios, Q is the quantity that is repeated. So if you can recall what you have learned in primary school, there is something that you might have heard of, which is repeated identity. So using this concept, we could apply it here. And in finding the ratio of P to R, we need to ensure that the quantity of Q is maintained as the same for both sets of ratio. So let's put down the information given to us first. First thing that comes to mind is with regards to the second set of ratio, how do we remove the decimal? So in removing the decimal, what we can do is we can actually multiply it in terms of 10, 100, thousands, and every time you multiply it by a multiple of 10, what happens is that it actually helps to move the decimal point more and more to its right. So if I look at 0.65, I need to multiply it two times, um, pardon me, I need to move the decimal point two times to the right in order to get it out of get that decimal point out. So this means that I have to multiply the ratio by 100. This means that 4.2 has to be multiplied by 100 as well, and that will give us a 420 to 65. Following that, let's leave this in the simplest form. We have 84 to 13. Now let's take a look at the first set of ratio where you have Q being 4. Now, how do we bring 4 up to 84, which is the quantity of Q in the second ratio? You will notice that if we were to multiply it by 21, we will end up with Q being 84 units. Okay, and that would give us 105 to 84. And since the quantity of Q remains the same, therefore we could actually place the three quantities side by side as 105 to 84 to 13. Finally, P to R is written as 105 to 13. Check that it is in the simplest form. So this would be the answer. Following that, let's take a look at BSS 2022 EOY Paper 1 Question 4. Express each ratio in its simplest form. So when we talk about expressing ratio in the simplest form, we need to take into consideration a few things. No decimals, no fractions, and all quantities must be in the same unit of measurement. Now, looking at part A, you have a ratio between two fractions. So how are we going to remove the fraction and form a ratio in the simplest form? So in order to remove the denominators, what we can do is to find an equivalent ratio such that it can be obtained by multiplying both quantities, by the LCM of both denominators. So looking at both denominators, 10 and 6, when we find the LCM, that gives us 30. So we multiply both quantities by 30. And from here, you will realize that we actually end up with 9 to 25. No decimals, no fractions. It is definitely in the same unit of measurement if there is any, because there is no unit given over here. Hence our answer, 9 to 25. Next question, 0.5 km, 8 and 1 out of 10 meters, 20 cm. Ooh, this has the whole spectrum of decimals, fractions, and units of measurements that are not the same. So you can see also it is the difficulty of this question is reflected in the marks given. It is 2 marks. We have to dedicate time for conversion of the unit of measurement to be the same first. So the first thing that we're going to do is decide which unit of measurement is most appropriate in this case. If we want it to be having no decimals, no fractions, it will be best to consider bringing it to the smallest possible unit of measurement, which is centimeters. Now let's convert 0.5 km into centimeters. And the first step is to change it into meters by multiplying it by 1,000. So that will give 500 meters. And 500 meters, you convert it into centimeters, you multiply it by 100. So we end up with 50,000 centimeters. Next, 8 and 1 out of 10 meters. In order to change it to centimeters, we convert it by multiplying it by 100. And we get 810 centimeters. Finally, 20 centimeters is left unchanged. And at this point, you notice that while all the units of measurement are already the same, we could eliminate this because they are in the same, the units are the same, right? So if the units are the same in a ratio form, we do not write it down. Let's move on to simplifying. So you notice that each of these quantities end off with a 0, and this only means that they are all multiples of 10. We divide by 10 to each the quantities respectively, and this will be our answer. Let's move on. Next question, CSS 2022, paper 2, question 7. And you will notice that this particular question is rather lengthy, with a lot of information, and furthermore, it is from paper 2. So you can notice that you can expect that there is much more follow through for this question as compared to the first 2 questions that we have done. Let's read. During a warehouse sale, cloths are being sold at a flat rate. Okay, flat rate means that regardless of the material used, it is the same cost for a particular length. So a tailor bought 100 meters square of cotton, dry fit, and stretchy cloth in the ratio 6 to 15 to 4 respectively. And she paid a total sum of $800 for the cloths. The tailor proceeded to create shirts using the cloth purchased, and each shirt requires 0.5 meters square of cloth. Calculate the amount she paid for the cotton cloth. Let's see. For this particular question, we are talking about the amount paid for cotton. Let's go back to the paragraph of information given to us and see about the information that is needed to work out something for part A. We are looking at amount she paid. Okay, so in terms of amount, the only amount where you have money involved is that the total sum is $800. And because it is $800 for everything, we need to know the ratio, right? The proportion of cloth being bought. So 6 to 15 to 4 is quite important. From there, we also need to know that in the ratio given, which quantity refers to cotton. Now, let's put down the information we have. Okay, all the cloth that is being bought is in these units. Let's find the total unit first. And these number of units actually make up a total of $800. We want to find the amount that she paid for cotton cloth. So cotton cloth will be the first quantity. Let's work on finding 6 units. So if we know that 25 units is represented, pardon me, $800 is represented by 25 units, one unit will be 800 out of 25. And from there, to find 6 units, it's to multiply it by 6. And so we have $192. That will be the amount that she paid for the cotton cloth. Now moving on, we are asked to find the amount of cotton cloth bought in meter square. I'm going to use a green highlighter. We're looking at amount of cotton cloth bought, meters square. So this is no longer about talking uh, about looking into the cost. It is about looking at the length, the area that is being bought, and which cloth, cotton. We need to also focus back on the ratio and the total amount of cloth bought. Okay, now we can see that the ratio remains the same, which means that 25 units of cloth is in fact 100 meters square. So I'm going to put this down. And we want to find 6 units of cloth. So we find 1 unit first, which is to take 100 out of 25. And from there, we multiply by 6. And we get 24 meters square of cloth. So this is part B. Part C, we are asked to calculate the selling price for one cotton shirt, given that the tailor intends to make a profit of 30% on all the cotton shirts. Profit of 30%. Okay, let's see. In part A, we realized we have found that she has spent $192, right, on buying the cotton uh, cloth. To make a 30% profit means that this being 100%, we need to find 1% and we multiply by 130 times. Okay. So let's find the selling price for all cotton shirts. And that will be $192 out of 100. This will give you 1% times 130 cents. Times 130, that will give us $249.60. How do we find the price for each cotton shirt? First and foremost, we need to know how many shirts can be made. So let's see if there's information given. Yes, each shirt requires 0.5 meters square of cloth. Okay. So we could write it down as 0.5 meters square of cloth is for one shirt. We have found that there are 24 meters square of cloth in bought. So how many times of 0.5, right, will actually make up 24? That's 48. Now, how did I get 48? To find the number of times taken, we're going to take 24 divided by 0.5, and that gives us 40. Therefore, we have 48 shirts. Okay, that costs a total of $249.60. To find the cost of one shirt, is in cotton, will be to take $249.60 divided by 48. And that will give us $5.20. So our answer, $5.20. Moving on, let's take a look at the next question. KSS 2022 EOY, Paper 2, Question 5. Bill has some red, blue, and green marbles. The ratio of red marbles to blue marbles that he has is 3 out of 4, and the ratio of red marbles to green marbles that he has is 4 to 5. Find the ratio of blue marbles to green marbles that he has in its simplest form. Okay, let's put all information down. So we have red to blue being 3 to 4. We have red to green being 4 to 5. Do you notice that this question uses the concept of repeated identity as well? Because red is the quantity that is repeated in both ratios. So between 3 units and 4 units, the LCM of 3 and 4 is 12. How can we make a ratio where red quantity becomes 12? An equivalent ratio. So for the first ratio, from 3 to be 12, we need to multiply it by 4. And for the second ratio, we multiply it by 3. And therefore, red to blue to green is 12 to 16 to 15. Answer for blue to green marbles, it will be just 16 to 15. This is straightforward. Now let's take a look at the next portion, which can come across challenging. Bill exchanged 5 blue marbles and 2 green marbles with a friend for red marbles. He will then have equal number of red, blue, and green marbles. Calculate the total number of marbles that Bill has. First and foremost, let's put down the ratio between red to blue to green marbles. And we also want to calculate the total number of marbles. Now, this is important to put down because if you notice, whatever that Bill has removed from blue and green, okay, the units containing blue and green marbles, he is going to exchange for that same number of marbles, but it's in red. So the number of marbles essentially remains the same. The units will be 12 to 16 to 15, and in total, it will be 43 units. Okay, now let's see what happens during the change. For blue marbles, it will be to remove 5. from it. And for green marbles, we are going to remove 2 from it. Okay, so you notice that there are 7 marbles being removed. And the 7 marbles are going to be put in here. Okay, perhaps to make it less confusing, I will put down U for 12, 16, and 15, and 43, so that you can see that it is not the number, the actual number of marbles, but we are looking at that, which is in blue ink, in terms of units. And whatever that is in orange is the exact number of marbles. Next, let's see what we can do to solve this question. He will have equal number of red, blue, and green marbles. Oh, okay. So at the end of the day, red marbles will be 12 units plus 7. At the end of the day, blue and green marbles will be 16 units plus 15 units minus 5 minus 2. But they're not equal yet because they will, if the question says he will have equal number of red, blue, and green marbles, all of them having the same. If I were to lump green and blue marbles together, this makes one, this would mean that green and blue marbles will be twice compared to the red marbles at the end of the day. Are we seeing that? Allow me to explain further. At the end of the day, you will have equal number of red, okay? 1 unit left, 1 unit at the end of the day. Huh? This is 1 unit. This is 1 unit of blue. And this is 1 unit of green. Okay. Now, when I bring blue and green marbles together, you can see that this now makes up 2 units. And for red, it is just 1. So what can I do to even it out? To even it out, I will need to multiply the red marbles by 2 so that it will become equal to blue marbles plus green marbles. Okay, I'm actually forming a linear equation. This is a linear equation question. Now let's simplify. So you notice that on the left-hand side, we could simplify by expansion. And on the right-hand side, we could combine some terms. Now let's shift the terms around. 31u goes to the left and 14 goes to the right. So hence u will be 3, or 1u will be 3. Total number of marbles that Bill has remains at 40, as 43 units. So 43 units will be equals to, so this will be the answer to the question. Let's take a look at the final question. The ratio of Lionel's expenditure on food to his expenditure on clothes is 5 to 7. The ratio of his expenditure on food to his expenditure on transport is 3 to 2. Oh, this is yet another repeated identity question. The third repeated identity question we have come across so far in just this one handout. He spends $132 more on clothes than on transport. Find Lionel's total expenditure. So let's list down the information given. Food to clothes, 5 to 7. Food to transport, 3 to 2. So food is the repeated identity. Hence, let's find the LCM of 5 and 3. which makes 15. So we need to change the quantity of food to be 15 and find equivalent ratios to both sets. So for the first set, we multiply it by 3, and the second set, we multiply it by 5. And hence, food to clothes to transport is 15 to 21 to 10. Now let's bring in $132. This is the comparison between the amount spent on clothes as opposed to transport. So clothes is 21 units, transport is 10. That makes a difference of 11 units. So 11 units is $132. And to find the total expenditure, perhaps what we can do is we could add a fourth quantity, total, and we add up 15 to 21 to 10, that's 46. Yeah. Now coming back to where we stopped, 1 unit will be 132 divided by 11, which is 12. And 46 units will be 46 times 12. So we have $552. So this concludes our Handout 1 on the topic of ratio in particular. I'll see you again in Handout 2 and Handout 3. So take care